Today I'm looking at this old Pyramid Phase 3 13.8 volt power supply that I've had for, I don't know, about 30 years maybe now. And it suddenly stopped working on me, so I've already taken it apart, as you can see. And I've done a little checking on the unit here, and I believe that the output pass transistors are in need of replacement. So what I've done here is I've turned the unit on and I've put the voltmeter in the output terminals, and you can see here that with the unit on and the test leads in their correct position, there is no voltage output. However, if I start probing around, I do find that there is 24 volts on one leg of the pass transistors, but there's no voltage when I move the needle to the other leg, which indicates to me that the transistors are opened. Well, I've unplugged the power supply, and you can see here, I'll spin it around. I've also mostly disassembled it, and you can see here's the rear heatsink where the pass transistors are mounted. So what I'm going to do now is remove these from the power supply and replace them with some new ones that I ordered on Mouser.com. While I'm at it, I figured that I would also replace all of the capacitors, and I've also ordered all of the capacitors that I need for this power supply. These are the big ones that are over here on the board, but I also have the other three smaller values as well, so I'll replace all of those too. And I'm going to start with the big ones because I was able to find these in my pile of capacitors that I ordered a while ago for various different projects. And you can see here the capacitor that I chose to replace it with is a Nichicon 4700 microfarad 25 volt cap, and it's not quite the exact same size as the one that's in there, but the lead spacing should be the same or close enough, so it should work. So I won't bother showing all of these, I guess, but I'll at least show the first one. So I'm going to put a little bit of flux, and with a little flux on there, I am just going to heat this up with my soldering iron and flow a little bit of new solder in there if I can get it to heat up. And that'll just help kind of get everything going so that I can remove all of the solder off of these. And these solder joints take a little bit to heat up because there is sort of a copper plane area here on the board. Although it's probably not very thick copper, it still is sinking a little bit of the heat away. So with a little bit of fresh solder on there now, I should be able to suck the old solder right off of there. Let's see how it works. And again, because of all the copper on there, it might be advantageous to try and heat that up a little more. Okay, with most of the solder out of there, I'm now just going to try and heat this up and wiggle it out. Looks like the closer lead is free. This one is just being the tricky one. Okay, now that's out. Okay, and there's the old capacitor. It really doesn't look like it's in bad shape, but I figured since I was in here, I'd replace all the capacitors and stuff, and the thing should be good to go for another 25 years. Okay, so you can see here I've got both of the big caps removed, and on this side of the board there is a silk screen that indicates the polarity of the cap to be installed. And what's interesting I see here is that they've got two different lead spacings, or the ability to use two different caps with two different lead spacings rather. So anyhow, what I'm going to do now is install the new cap in the correct polarity with the negative side or the striped side as shown. And I'm just going to install it like that, and I'll fan the leads out just a bit to kind of hold it in there, and I'll add a little bit of flux. I suppose I could have cleaned up those solder pads a little bit before I started, before I started the resoldering process rather, but it should be fine. I'm not going to worry too much about that. Okay. And that, as you can see, is now soldered in. Well, you can see here that I've got all of the capacitors replaced with new ones. So I've got the two big ones here, one in the middle, and then two smaller ones over here on the side. And that's it for caps on this thing. You know, reasonably simple circuit, so not too much going on. And like I said before, the old caps were probably fine. Probably didn't even need to bother with this, but since I had it open, I figured I'd go ahead and do it. So now I'll turn my attention to the replacing the transistors here. And before I do that, what I want to do is make note of where all the wires go, which colors go to which terminals, and so on and so forth. So I'll just put a little flux on each of these solder terminals. So I'll just start here and work my way around. And okay, so you can see there what was actually going on, depending on how the camera was pointed here. This wire was actually soldered through these two tabs here and kind of keeping everything together. So I'll want to clean those up before I solder any new wires on there. Okay, with all the wires removed, now all I have to do to get the transistors off is loosen these nuts. Okay, you can see here with the center terminals, there's an outer nut that holds on the terminals on each of the two studs, and then there's an inner nut that'll need to be loosened that actually holds the transistor in. Okay, and as you can see with the nuts and bolts out of the way, everything just starts to kind of fall out. Now this transistor wants to come out first because you can see that this plastic insulator that should have had, you know, a complete tab here with a hole in it is broken off on both sides. On this side, it still seems like that tab is intact, and that's what's holding the kind of the transistor in. So I'm just going to leave that for a minute, set this aside, and here you can see the transistor, and you can see the two pieces of that ear. I'll save those anyway for now. And then you can see there's a little bit of a sill pad here on the back of the transistor that needs to be removed and saved. And there is the transistor itself. Yeah, from the looks of it, I've still got a little bit of solder on those leads, and I don't want to break those tabs, so I'm just going to cut the leads off of the transistor, since I'm not going to use those again anyway, and that should help free everything up. Yeah, there it goes. And there's the insulator with the tabs as they should be. Okay, and here are the transistors that I got from Mouser, kind of packaged up nicely here. In this tape and cardboard and foam sort of arrangement. This little piece of foam is not really needed, but this is a nice piece of foam here. This is probably electrostatic foam, I would think. So this could be useful for something else. I'm going to save that, make sure I don't throw it away. Okay, and here's the shiny new transistor that I got from Mouser, and it looks like it was manufactured by ON Semiconductors. That's their logo there at the top. And then 2N3055G, which I'm not sure if this is what I ordered or not. I don't remember, but the old transistor is not a G model, and I'm going to have to double check the data sheet on this and make sure that this is compatible with the old one. Off the top of my head, I'm not sure if this is a significant difference or not. Okay, so I'm back looking at the power supply again after another break in the action, and what I'm going to do is start reassembling everything. So you can see there what I've done is I've taken one of the new transistors and I've put the insulator pad back on the back of it, and I'll do the next one here as well. And now I should be able to put these in the heatsink. You can see this is the inside surface, and that's the outside surface. You can kind of see that over the years things have worn off. The anodizing or whatever's on here is worn off, except underneath where the old transistors were. So what I'll do is I'll take the first one. You can kind of see the holes are drilled to match the transistor, so I want to make sure that I orient those correctly so that everything lines up. And I'll throw that in and just make a quick note to make sure that the insulator pad is completely covering everything there. Okay, so the next thing I'll do is put this insulator pad back on, and you can see it's got some raised surfaces there on one side, and those are that's the side that's going to go towards the heatsink and kind of line everything up. And now I'll put one of these bolts back in just to hold it in place. And I'm just going to finger tighten this for now. I just want to hold it in place. And I'm going to do the same thing with the bottom one. Okay, so now I'm going to put the plastic piece on, but in this case, if you'll recall, the plastic piece is broken. So I've saved the broken pieces, and I'm just going to put those on the leads, and that'll just kind of help keep those leads from shorting against the case if they were to get bent or something. And then I'll put the rest of the plastic piece in. And this won't be perfect, but it should hold it together. I'll kind of bolt this into place temporarily. Okay, and that's sort of what it looks like there. Okay, the next thing I've got are the two tabs that connect to the yellow wire and also connect the two collectors together. I've got the tabs in the handy helper there, and I'm just going to take my soldering iron and try and melt that solder. You can see that kind of had some tension on it. And now I'll just try and clean. Alright, so now I'll try and suck the solder out using this solder sucker. And that didn't work too well. I'll try it again. I don't know how well this thing works. There. Okay, I think I'm going to just try the solder wick here to try and get the rest of this solder out of here. So that hole is nice and clean. So now I'll do the other side. Is now clean, although there's a little bit of junk on that tab that I'll clean up here. Okay, before I put the tabs on, I'm going to put the screw and nut on each transistor first. Now what I'll do is throw the tabs on. So now what I'll try and do is line up that hole, or line up the holes in each of the tabs, and then just kind of tighten these nuts up. Okay, that should be good enough. And you can see I've already creamed the leads on this transistor. So I'll bend those back. And it looks like I creamed this one too, so bend that back. I'm about ready to solder on the red wire. And I actually had to go back and look at my old video footage to make sure that I had everything oriented correctly, as it's been a month or two since I've looked at this thing anyway. So I've got the wire held on to one transistor with a pair of hemostats there, you can see. And now the other one, I'll just hold the wire up against the pin. Actually, before I do that, I'm going to tin this pin. And I've got this piece of solder. This is left from an old roll that I've had for quite a long time. So this will probably be the last usage of this solder. So I've got a little bit of solder on the pin there. And now I'll just try and tack that on. Okay, I'll hold that while it sets. Now I think I want to put a little more solder on there. It may not be real visible in the camera because of the way the heatsink is, but and repeat the process on this side. Keeping in mind that I will have another wire to solder on there, so. And first I'll just try and tin the pin a little bit. Get the solder flowing on the pin, and now I'll flow that wire in there. That should be good. Now I've got the power supply back over here and ready to go. And I think the first wire that I'll work on is the yellow one. I think what I want to do is cut this wire, this old soldered end off. And now I'll kind of expose some new copper. Or, well, I guess in this case aluminum. And that way should be able to fit it through those two aligned tabs, and that should go through. But now I don't want this to short to the case, so I'm gonna cut this really short, kind of like that. Alright, so I'll put a little flux in here just to try and help get everything cleaned up and flowing well. And now I've got, and I think before I try and do the actual soldering, even though I've got the wire in there, my intent is going to be to kind of tin these a little bit, but if the wire happens to solder while I'm doing this, that'll be fine too. Okay, so I didn't quite like the way that the wire seated in here after I soldered it. It looked like it was touching the case after all, even though I tried cutting it short. So I pulled off that one nut, And I'm just going to bend this up. Maybe you can see in there. You can see the wire is through both of the tabs. They're soldered fairly well, but that wire is just hanging down more than I expected it to. So I will try and cut it here without cutting anything else. Now while I'm at it, before I put that tab back down in place, I'm going to put some Kapton tape in here. Now, as you can see, it probably would have been a better idea to do all this before I soldered on that red wire. Okay, so we got one piece of Kapton tape in there, and that should be plenty. I think Kapton tape has a pretty high dielectric withstand rating, so we don't need more than one piece. And the way that I've done this, I'm fighting myself anyway. If I had thought this through, I would have put the tape down before I did anything else. I would have put a couple pieces down, but this should be fine. I've trimmed that extra piece of wire, so it's not even really needed. So the next thing that I'll do, I think, is solder on this red wire. So I'm going to cut this old end off and start over again with a new piece. And again, I think if I had thought this through, I could have stripped these ahead of time before starting. But this works too, I guess. I'll dab a little bit of flux on there, and I'll tin that wire up. And since I've used up finally more or less the last of my old solder, I'll go to this here. This is a little bit thicker solder. I usually like to use the 20 core solder. This is 32, but it should still work. Okay, I've got that red wire on. You can see there, not the best soldering job in the world, and I seem to be batting 1,000 tonight. You can see I hit the insulation on that yellow wire. I didn't go all the way through it, but it nicked it anyway. Okay, so now the next thing that's left, I guess, is to solder on the blue wires. And again, those are probably the first ones I should have soldered on, since they're furthest away from me in the orientation that I have everything set up here. But anyway, you can see I tinned those pins, and I guess I'll solder this wire on first. Okay, now I'll solder on the last of the blue wires. Okay, and there you can see everything soldered back in place. Not the neatest job in the world, but it really wasn't that great in the first place, so it's not like I made it any worse than it already was. Now that everything's all soldered up here on the back, I can start the reassembly process of all the hardware. And I think the first thing I'll do is remount this circuit board in the chassis here, and that's just held on with these couple of threaded clips here, so I just have to get the screws in and get them started here. Now that that board is secured back in the chassis, I can mount the heatsink and transistor assembly to the rear here. So this is held on similar to the circuit board. It's just got some screws that go through the holes in the chassis, but these are more like a sheet metal screw. What I'll do next is put this LED back in its hole here so that we have the visible indicator light, and that just sits in there, I guess, just held in. It looks like this may have had some clips or something on it at one time that are either a little bit worn out now or broken, but it should stay in there okay as it is. Okay, now I'm ready to put the cover back on. And let's see, this just goes over the unit like this, and then I've got the remaining screws here that I should be able to put on if I can get everything lined up. Okay, so we're ready to test this power supply out now. I've got my meter hooked up and ready to go, so I'm going to plug the power supply in. I'll make sure it's off first. I'll plug it in, and no smoke came out, so that's good. So now I will flip the switch and let's see what happens. Okay, it looks like it's working. We got 13.8 volts, which is what we're supposed to have, and the red light is on, so that's a good sign. Now I'll put a load on this thing and see if it can actually provide power. Okay, so you can see here I've got this old KDK 2-meter radio connected to the power supply, and it's just in standby mode right now. I've got a dummy load on the back so that I can transmit with this thing, but it's in receive mode, and I don't have a current meter on this, but you can see that the voltage is still at 13.8382 there. It flipped a little bit, but it seems to be holding steady. Okay, if I turn the squelch down so that it's receiving some static and drawing a little more power, you can see there that the voltage is still staying steady, and if I put the radio, it's on high power, and if I key it up and throw a dead key there, you can see that it's still, 13.82, and the radio seems to be functioning normally. Okay, so I've actually switched meters because it occurred to me that that other meter that I had hooked up doesn't really have any capability to measure amperage. It can only measure, I think, up to a couple of microamps. So I had to switch over to this older meter, which isn't quite as accurate, but it'll give us a good enough indication as to what's going on here with this meter, or with this power supply rather. Anyway, the radio is in complete standby mode and squelched. So now let's put a little audio into it. And you can see that the current draw went up a tiny bit. And if I turn the volume up, that makes it draw a little more power. So that seems to be good. So it doesn't seem to have any trouble supplying 0.4 of an amp or so. So now let's do some transmitting and see what the current draw is like. Okay, so there's 2.8, 2.9 amps, and if we modulate the radio, that should fluctuate a tiny bit, and there you have it. Okay, so that seems to be working. Just out of curiosity's sake, we'll put this down on low power, and we'll check the current draw there, and as expected, it's less. So the power supply seems to be working good now, so I can put it back in use. Okay, well, after several months of starting and stopping on this project, it's finally done. The power supply seems like it's repaired, and I can get on to the next project. If you found this video helpful, please give it a thumbs up. And if you'd like to leave a comment or subscribe, feel free to do that as well. Thanks for watching.